open on YouTube. Hit record. Finish a wee bottle of wine and a smoothie. Lovely. Probably looks terrible, but this is mulberry picked from the front garden. All right. So the purpose of tonight's segment is to basically run through the steps I'm going to be working on for my next code project for getting things set up here. Actually, it's kind of important that I pull Kinto into this. So we'll go ahead and do that. There we go. Just like magic. All right, let's get started reading this out. Guess we'll put a segment together. Kinto is an isometric avatar chat platform coded in WebRTC, React, Canvas, and WebGL. It's kind of a test bench for me. I've used it to code all sorts of things that I find interesting. And one of those things we're going to talk about is taking a webcam feed, so like you see me right here, and then using isometric blocks and tiles to render that in real time in the game. So that's what I'm going to explain tonight. Not going to try to code it this time of night. Took me long enough getting set up here. It's a pain in the arse. So YouTube is a tough one, man. Okay. So, hey everyone. Welcome back to the channel, or the segment. Today we're going to take a standard webcam feed and turn it into a real-time isometric block representation. Imagine your webcam image transformed into a dynamic 3D styled pixelated effect, where each pixel becomes a small block in an isometric world, just like you see here and here. We'll break down step by step using JavaScript and the Canvas API, and some simple geometric transformations. And by the end of this little series, I'll have an interactive real-time isometric effect that responds to your movements on camera. So we'll get started here. So what am I building exactly? We'll take a live video input from the video Hear my voice delay in my headphones is a nightmare. I think I'm convinced that audio works, so I'm gonna kill that and then run through this again. Okay, monitor off. Oh, that's so much better. Just music now, that's the way I like it. Right, welcome to the glorious America, where I'm recording this segment tonight. So welcome back to the channel. Today we're going to take a standard webcam feed and turn it into a real-time isometric block representation. Imagine your webcam image transformed into a dynamic 2.5D pixelated effect where each pixel becomes a small block in an isometric world, just like this one. Break it down step by step using JavaScript and the Canvas API and some simple geometric transformations. And by the end of this series, I'm not going to do it in this video tonight, I'm just getting set up. We'll have an interactive real-time isometric effect that responds to your movements on camera. So let's jump right in. So what are we building exactly? Well, we'll take a live input from the webcam by requesting a media stream. We'll downscale it to a low resolution grid, such as 100 by 100 pixels. And you'll see why in a minute. To make it manageable to process, essentially, because too many pixels otherwise. We're going to extract the pixel colors from the video feed and reconstruct the image using 2.5D style isometric blocks, and then continuously update it in real time to reflect movement. So instead of just seeing me here, bored in pixels, you'll see me represented in blocks. I know, really fun, right? So first we need to set up a media stream request, or the heady there. That's what my face is here. Can work through some of this code when I actually get coding. So what's happening here? Well, essentially we want to create an invisible video element that plays the webcam feed. And we're going to request permission to the user's camera to do that. It'll just be through the browser. And once granted, the video stream is assigned to that video element. We'll then move on to setting up our canvas for rendering. So essentially we're going to render an invisible video, and then we're going to sample that video every frame or so, at least 30 times a second. No less than 24, or it becomes too jittery to the human eye. So we'll set up a canvas, HTML5 canvas, where we capture and downscale the video. This helps us extract the pixel data efficiently. And this is something what it looked like. Just going to do a resolution of 100 by 100 pixels. So essentially, as I just described, we create a small hidden canvas that captures each frame from the video, at least 24 frames a second. The canvas resolution is deliberately low, like 100 by 100 pixels, to reduce the computational load and create a blocky effect. We'll define the block size, it's already defined. It determines how large each pixel appears in the final isometric rendering. And then we'll have to convert those blocks into isometric space using very simple math. So we continuously draw frames from the webcam onto the canvas. We extract the pixel data for the current frame, literally going through every single pixel in that frame. We're going to map it to an isometric cube, and then we're going to tint that cube to be the color of that pixel. We'll then send that pixel data to a render isometric function, which will handle transforming it into 3D style blocks. Continue on here. And here's the fun part. We'll loop through each pixel and draw it as an isometric block. And I'm also going to implement depth here. I think I'm going to use darkness as a way to determine that. The darker it is, the more sunken, the brighter the pixel, the higher the depth of the cube. So I'm going to skip over the code because it's not entirely relevant. I just want to get this idea out to get a wee clip together. So we're going to create a new canvas for the isometric rendering. So essentially we're going to have two canvases, it looks like. We're going to have one that does the sampling and then another that actually is visible and renders those sampled and mapped pixels to the cubes. We'll clear that canvas every single frame. We'll look through each pixel in the 100 by 100 grid, extract its color, and then pass that down. And some fun code about how that will be done right there. We'll actually be using an image. We will not be using this, but it gives you an idea. So we're going to calculate the isometric X and Y positions where the pixels should be mapped to with the cube. We'll set the fill color to match the original pixel, so that way color will be carried over. And then we draw apparently a rhombus shape to simulate an isometric block. And this method repeats for every single pixel, resulting in a fully transformed webcam feed. So you see why it's important to first take the scaled down 4K webcam or even 1080 or even 720 and get that to something more manageable, because this is all running in your web browser. So we're just going to start with 100 by 100 pixels, see how it works on the computer, give it a test on the iPhone, go from there. And that's it. Once we've accomplished that, we've successfully taken a live webcam feed and turned it into an animated isometric pixel display. And this is going to be a fun thing because we can actually make some games out of it. Imagine the map of the world reacting to your hand or your face for some reason. I'm just kind of doing it for the effect. That's where I'll start, and then I'll figure out a practical application for it later, like most of the fun things I code. And yeah, I think I'll do it for tonight. Just wanted to run through this. As you can see up here, this is Kinto. There's a ton of complicated features in this. This is just a simple wee room, not to blow up the situation here. Like if I go ahead and type in the chat, type in hello world, it'll read out the message into the stream, create an avatar for it ideally. Let's see if all that's working. Well, of course it's not. Why would it be working? Must be a problem with the bloody API key. No, the first time. Yeah, that's what I'm assuming. Let's see, did the video ID change? It always changes at the wrong time. Yeah, it should be working, but isn't it? So you know what? We'll kill it in here. I'm going to go try it in another room. Let's see what we got here. Everything's kind of too busy. What can you do? What can you do? All right, let's see if I can get it working in this wee room here. Test the text-to-speech system for YouTube real quick before I dip. Join the minefield. Hello, buddy. There you are. Nice to see you. Go ahead, drop the video ID in my UI here.
Hello, world.
Oh, there you go. So it was just that room that was corrupted for some reason. But that is reading from the live chat. Don't believe me? Go look at live chat. There's my message there. Tell me it's not working. I'd appreciate it. Before I get bored. I'll just finish this off. Oh, the cool thing, let's see. Type dance, go have a wee dance, because I got some music playing. Let's see what that does. There you go. See? Fully controlled by the stream. I like seeing stuff like this. I like seeing people integrate games, projects, or live stream control. Can jump. Can move to the right. Move down. I could go ahead and spawn a collectible into this world that you could pick up in the chat. Let me go ahead and do that real quick. I have to do it in an administrator account, but that's okay. Let's see what we got that's collectible in the catalog. Give me a quick minute here. All right, how about a gold bar? That's always good, isn't it? So I'll buy a couple of gold bars and I'm going to pop it right in front of my YouTube comment controlled avatar. Because I'm cheating tonight. That's okay. All right, if that all worked, you should see that. Let me scroll in a wee bit. For fuck's sake, man. It was going so smooth till I lost the headphones. All right, let's get on with it. So, get out of the way. Go back to the live chat. We'll type move down in the live chat. You should pick that item up. Yeah, that's what I'm talking about. So now, that live chat, which is me, just got 2 gold. That's cool. I got to finally display that. Drop a like or subscribe or whatever you want to do. But appreciate you hopping on tonight, guys. Have a great day tomorrow. Make the best of it. Weekend's coming soon. Right, buddies?